Welcome back to Worth the Effort, and in this video I'm taking this conglomeration of steel, rubber, wire, grease, and paint and turning it into a utility trailer. Something that I'm going to use in the future as a foundation for a teardrop camper build, but most of y'all can relate to it because it's just a utility trailer. Now what's going to be different on this one is the fact that I'm new to metalworking. So there's going to be an overall theme to this video. It's called planned incompetence. Now, the materials I'm using in my trailer is an example of that. Most trailers in this category are made up of angle iron. This is an example of a heavy-duty angle iron. It's just two pieces of metal at 90 degrees. And if you go to a trailer supply place, or even the ones you see outside big box stores or farm stores and stuff like that, they're built by companies and the employees have lots of experience and they have to go through quality control checks and stuff like that. So a lightweight angle iron built to that quality is all that's really required for this caliber of utility trailer. But I can't trust that I'm going to have the same skill level as somebody that's been welding for 10 to 20 years. So I'm going with a lot heavier duty materials. I'm using C-channels instead of angle irons, and specifically I'm going with C-channels that have a pretty heavy weight per foot, and that gets it a little bit thicker than it needs to require. This is total overkill for this capacity of trailer, but here's the advantages. So you have a kind of a standard trailer design, something that I'm going to be somewhat following. And if you use thin wall angle iron, basically you have one shot at each face to get the weld perfect, and a fully trained welder can do that one. But that basically only gives you two faces to weld. If you're using a C-channel, and specifically a really thick C-channel, you basically give yourself 1, 2, 3, 4, 5, 6 chances to weld faces, because it's thick enough that you're not going to blow through it if you weld from both sides. So if the penetration, meaning the amount of weld that goes inside the other metal to join the two, isn't 100% perfect, well, I basically have 4 more chances to get it right. So even if I'm 50% of what a pro is, it's going to be strong enough for the task. Now, that's my thinking. The other advantage to C-channel in my mind versus what a lot of home-built people use is square tubing is, well, with the square tubing, A, you only have 4 chances versus 6 to get the welding right, because you can't weld on the inside of the tube. And B, if your weld isn't perfect all the way around and maybe you have pinholes and stuff like that, square tubing can rust from the inside, and I've read about that a lot in these DIYers where they just have a rust problem 5-10 years down the road because of the square tubing. Well, with C-channel, even after it's all welded together, I have access to every single face inside and out to apply primer and paint, and if rust ever becomes an issue, I'll be able to see it before it becomes too bad and grind it off and reprimer and paint it. So to me, C-channel seemed the best option for building my trailer because of my skill level. Not necessarily that it's a little bit more structural sound than just simple angle iron. The two big downsides to this compromise on my skill level is that this is going to weigh a lot more and it's going to cost probably twice as much. But in the long run, I thought that was a fair compromise for my peace of mind based upon the skill I have right now. The other issue I have is I'm not a very good technical designer. I don't have those CAD skills and SketchUp and Fusion 360 that a lot of creators do. I design on paper with pencil and stuff like that. So most of my measurements are done from the piece. I stick one piece up to another, I mark it, and then I cut it. And I'm going to be taking the same approach here because that compensates for my lack of skill in design. So my first major problem was with the axle I bought. I'm going to use this 3,500 pound axle mainly because it has attachments for trailer brakes and I really wanted that on my camper. My problem is, I have another video where I went through all the reasons why I made specific purchases, so I'm not going to cover a lot of that stuff in this video. I'll just put a link down below to it. But my problem is when you buy axles of this caliber, they don't pre-attach the spring hangers that actually attaches the axle to the trailer. So because of my lack in technical design skills, I need these attached to figure out how to cut my seat channels to get it just perfectly. So my first step, I actually have to build up the entire axle with brakes and wheels and stuff like that so that I can figure out where to put the fender, because the fender is going to be attached to the trailer, and if I get this measurement off, it won't be covering the tires. So that's my first step. Build this up so I can figure out where the fenders are going to go so I can attach these to the axle, which will give me the dimensions I need to cut for the width of the trailer. Complicated, I know, but in the end, it just works out better for me to do relative measurements than measurements to dimensions. Okay, so I've been assembling all the parts I'm going to need for my trailer. I'm using all Dexter products. It's just from my understanding, it's a little bit more of a premium brand, but everything should work together. If I stick with one brand, that's my thinking. But this stuff is so standardized, from my understanding, is if anything goes wrong out on the road, I can pretty much get parts, you know, Wally World, you know, any farm place, Northern Tools, Harbor Freight, all that kind of stuff. A lot of these parts are pretty much standardized. I do have 2 electric brakes. Some information that I didn't know, and this is probably really basic information, but maybe y'all are beginners too, is you do have a left and a right side brake. The big difference is in the size of the brake pads, because evidently, even though it's a circle, most of your braking happens at the back side. So that goes towards the rear of the trailer, hence a left and right side. I have not seen anything that tells me that there's a left and right side on the drum, so those are pretty much interchangeable. This kit, it looks like the bearings came pre-packed, which was kind of nice, but on this one I'm left in the bag because the bearing popped out, so I'm going to have to put it back in. So it's just a little bit messy, and they seem to come with parts kits for them. Unfortunately, they didn't really come with any instructions, but from what I've seen online, that this is so simple, you can't really mess it up. There's very few things that need to be torqued perfectly. Those that do, I'm looking up, and that's going to be obviously the lug nuts and the bolts that hold this onto there. The other thing I got is the axle, of course. And once again, I went with the Dexter brand just so everything works together. This particular one I got, which is kind of a very basic standard one, comes with the spindles already attached, which I think is kind of nice. I believe a lot of times you have to buy them separately, and that kind of offset a little bit of the cost. You know, they do pack it in heavy with this Cosmoline, and from what I understand, we need to get all that off beforehand. But all the parts that you're going to need are already attached, so that kind of makes things simple. You're not having to buy them separately. I guess that saves you a little bit of money for buying a premium product. Now, something I'm trying, I haven't seen anybody else do it, but these cinder blocks, I've got those pieces I'm going to be welding onto it, setting there, so this thing is not going to roll around on it, so I can do work on either side of it. The other thing that I just learned was that whenever they make these trailers, you know, they put the manufacturer's label on them. That goes towards the back of the trailer. That way, the wires that run through the center of the axle to connect the 2 electric brakes, they're going to be towards the back. And also, whenever people do inspections on it, they always know where to look for the specs. So I accidentally took the sticker off of this one, but it's also engraved with the manufacturer and all the specs on that. So that goes towards the back of your trailer when you align everything up. Okay, I was an idiot and forgot to turn on my mics when I filmed this section, but installing the electric brakes was really simple. I mean, you basically just slid them on because they came preset. The bolts that were on here just slid onto the axle, and you put some nuts on them. The only concern I had was in the back of my mind, I seemed to think that there should be some kind of lock washer or something like that. It's just the bolt. So I went ahead and used some blue Loctite on it. It didn't say to do that one in the instructions, but I'm going to do it anyways. And you've got to torque them down to about 70 foot-pounds. but I can't get enough leverage on it right now, so I'm going to tighten them as best as I can right now, and then when I get the entire trailer built and the tires are on and you can put some torque on it, I'll go back and retighten those. Also, they come with some plugs for the brake adjusters. I'm not installing those now because I'm going to wait once again until the trailer is built and it's on the ground, and then I will adjust those brakes to the drums and plug in those holes so that water doesn't get inside the brakes. But other than that, this was really easy. Next, the drums go on, and these already had the bearings, the big bearing and the small bearing installed on it. I'm just going to take the time and put a little bit extra grease on the spindle itself before I throw this in. Once again, the instructions don't say to do that one, but can't hurt, and it makes sense to me. Remember, your parts bags that come in make great finger protectors for spreading this kind of gooey stuff all over the place. Next goes on this little metal gasket skew. Notice simple designs always seem to work best. It's not a complete circle, it's got that little cutout, and they actually ground down a little bit on that axle right there, so this thing won't rotate. So I can put that on there, then put the bolt on there, the nut on there, and tighten it down. And from what they say, the torque isn't really that important on this thing, which sounds scary to me until you see that clever little design that having that little flat spot allows us. So I tighten it up a little bit, back it off, and then just make it snug. And then you have this lock ring that's going to lock around the 8 sides of that and lock it to that little cutout. And voila, it's not going to twist off. After that, just attach the little seal with a mallet. Install the little cover, give it a good wipe down, and we are ready for wheels. And once it's all built and on the ground, I'll go back and retorque these down to factory specs, which I think is about 100 foot-pounds. Do you procrastinate? Do half-finished projects take up way too much space in your shop? Is your spouse's to-do list longer than a drugstore receipt, printed in 8-point font, single-spaced? Has not getting around to things provided passive-aggressive ammunition to those around you? Does the unexpected constraints keep pushing things back until you can get around to them? Will a mechanic only work on your vehicle when they can get around to it? Do your kids smart off to you saying they'll clean their room when they can get around to it? Does your boss say that your raise and promotion will be processed as soon as HR gets around to it? Is your cat's entire persona based upon the idea that if they get around to it, they might do it? Has your warm, heartfelt responses to requests morphed into, I'll do it when I can get around to it? Well, Worth the Effort is here for you. With a lot of research, experimentation, and prototyping, we have come up with the perfect solution. The Worth the Effort, round to it. Because when you get around to it, you'll finally be able to say you got around to it. And all those issues will go away because you got around to it. Besides, once you get around to it, do you really need to do it? Because after all, you have already gotten around to it. And if nothing else, your spouse can finally say, you got around to using a coaster. So get your round to it's today. They are the perfect gift for your wife, boss, sister, kids, mechanic, or side piece. You can get a set of round to it by following the link in the description down below or going to the Worth the Effort online store. While supplies last, limited time offered, and all proceeds do help fund content creation here on the Worth the Effort channel. All that simply so I could position the fender and make sure it covers the wheel, because this fender, you can see there's not much room there. So I got it on the outside. Okay, this is what I'm looking at. I got this hole right there. That's where the wires come out. So I kind of think I have to be on this side of that. When I position the fender, so it's just right on the other side of the tire, this is kind of coming down right in the middle of that gasket right there. Now my trailer is going to have a 1/2 inch of wood siding, which I would kind of like it to come past the metal frame a little bit so water will drip past the frame. So I have a 1/2 inch of play right there. So I think if I come a 1/4 inch past the little grommet on both sides to weld this piece on, I'll be all set. And if that's not right, I guess the last thing I do on this build was just going to be attaching these to the outside of my trailer, my camper. I'll probably be shimming them a little bit. Strange, I'm making decisions now for the end. And I have got to say that these fenders, I got them, they were inexpensive off of Amazon, and I guess you get what you pay for. This back panel, I mean, can you hear that? It's just tacked on in a few places. It's gonna come loose. So whenever I'm welding that up, I'm gonna take the time and re-weld these so that they aren't rattling and hopefully won't come loose. I say that just because, reiterate, you get what you pay for. Correction, I've got to leave at least this much space on that side of that wire hole, so it's gonna have to come in that much more. I'm also going to take this time now to go ahead and install the leaf springs and those U-hangers and all that kind of stuff. For the simple reason, I'm going to wipe it down the axle, get it primed and painted because it's already starting to rust as you saw in the video. And I'd like to look nice and last quite a while. So go ahead and get that done now, plus retorque those bolts. The first part of the frame we're going to build is the bed, or what most of y'all would be doing as a bed, but I'm actually doing as a foundation for the teardrop. And the general idea of this is I have one 4-inch I-beam, a heavyweight I-beam that I am going to be running down the center of the trailer, okay? Then I have those C-channels that I'm going to be running around the outside, like that. Those are also 4 inches, and I will be mitering the corners, putting them at 45 degrees, so that interior space will still be open. Then I have a bunch of 3-inch C-channels that instead of being upright like that, I'm going to turn down like this. So the flat sides on top, and I will be doing them every 16 inches or so across. Like that. The reason why I'm doing that is because in this position, it's still going to give you more than enough strength I need, but having that nice flat spot down below the edge right there will allow me to put wood substructure and insulation on my bed. If you're just doing a normal trailer, I would probably put it flush with the top, or maybe just a little bit down below if you're putting wood down as flooring. And that flat section would give you a nice place to put a hole and a screw into any wood flooring you're using. But that's the general idea I've got to start with. This overall length right here is going to be 9 feet, and this is approximately 5 feet. Remember, I'm taking the exact measurement between those two spots, accounting for the shackles. Now, most trailers do not have that center beam out there, and I've got two main reasons why I want to do that one. The first one being, I can put a trailer hitch on the back, and then connecting it to the trailer hitch on the front means I have a solid piece of metal from the front to the back. So if I ever get my 2-wheel drive truck stuck somewhere, somebody can actually pull me from the back of the trailer. If I don't have anything in the middle, well, you're more than likely just bending the frame whenever you pull on that back section. So it's going to be basically solid from that trailer hitch to the front trailer hitch attached to my truck for that reason. The other being, remember that planned incompetence? This gives me more places to weld on the frame in case my corner welding is not 100%. So that added weight gives me strength for towing and reassurance for my building abilities. So the first thing I need to do is cut that 9-foot piece, because that and these center pieces are the only ones that are going to be at 90 degrees. Just like that. After a bunch more yeses, I have all the main parts are cut to length, and I've got all the mid sections cut too. My next step is going to be kind of tricky for me because it's something unique that I've not done before. But this piece right here is actually cut to length to be from the inside of this C channel to the inside of that C channel, which means I now need to fit this to the C channel. So here's a cutoff of this C channel right here. And the idea is I've got to remove that much material from the top. And then I've also got to angle it somewhat so that this is sitting up against that, and this is sitting up in here. So as usual, I'm just going to, well, use the actual piece to make the measurements because it's more accurate for me that way, and then use whatever tools I have available to me to remove what doesn't need to be there. So I was getting ready to fit this, grind out what needs to happen, when I just now realized that a 4-inch C channel is not the same thickness as a 4-inch I-beam. What the hell, metal workers? I'm just going to have to flush it up on the bottom because that's where my tongue and more important stuff is, and I'll just do the woodworking up top, but still. Come on, that makes no sense to me whatsoever. Next, I'm going to take some of that angle iron. I use this stuff as an example of angle iron. It's pretty heavy duty. I picked it up at a salvage yard, a recycle place. You can buy this kind of stuff for 35 cents a pound in my area. I'm going to use this to make some corner braces. I'll just use my plasma to cut it in half, and then use a miter saw, chop saw to cut 45s. And then whenever we weld it up, that will brace all the corners. Just make it nice and neat and strong. Planned incompetence, remember? We're reinforcing with this stuff. And that is the last part I need to cut for the bed or foundation or platform of the trailer. After this, I'm going to spend the rest of the day just prepping all the parts to be welded, meaning all the parts that will be hard to wire wheel after it's all welded up. I need to handle that now. Any bevel or edge, I need to go ahead and bevel it so that the weld will have a place to go. And anywhere I'm going to be welding needs to be shiny metal. And it'll probably take me the rest of the day to handle all that stuff. So right now I have everything ready to start welding up, and now I just have to position it and get it as accurate as possible. This is the part I've been stressing about the most in this entire project, because I need this to stay perfectly square, but unfortunately, as you weld, metal moves. The heat makes it move around on you. So not only do I have to start out square, but I have to do it in an order so that the warpage counteract each other and it stays straight. Right now, I've just got it roughly done with a square for the initial layout, but I've got to position that center beam down the center perfectly. So what I've done is, you'll see blue tape on either end. One side of that blue tape is the center line, and I've done the same thing for that big beam. So I now just have to position it so that those are in center, and then I'll go around, square it up as best I can, and then I'm only going to tack that middle beam. And earlier in the video, I said that I cut those side pieces, those notches, out a little bit too big so that there's a gap there. You're about to see why. So what I did was I tacked it on either side of just that center rib. That way, with that little bit of extra gap I have on each end for that part I cut off, hopefully those tacks are pliable enough that I can now get 6 of these mid pieces on each side. Because if I squared it up any, I would never be able to get these in. So I had to have it locked in the middle so that I can at least slide these in before I welded up the exteriors. Also, it should be flexible enough that after I get these in, I can square it up by diagonals, tack the 4 corners, and if I screw anything up, I can at least grind off a tack to refix it, because getting this square is just way too critical to the success of this project. 125.5. So what that tells me again, it's a trapezoid. That's right. Those are fine. It's just a little bit wider there than it is there. And that's the worst thing that it could be. I have to have these 2 sides parallel. Those 2 I think can be off this way, but those have to be parallel. Get it straight over there. One line under 164. One line under 64. So the same. Yeah. One under 64. Okay, the stressful stuff is now done. I have every single corner is now tacked in 4 spots all the way around, and the center beam is fully tacked in 4 spots, plus that center axis. So that is pretty much locked in lightly. I'm now going to go ahead and tack in all these center sections, and the reason why I'm tacking goes back to that, welding creates heat, heat warps metal. So if I get all these tacked in, it should lock everything together, so whenever I do my long welds and add a lot of heat, it shouldn't deform too much. Right now, I have these 2 outsides perfectly parallel. I'm really happy with that. But corner to corner, I'm about 1/8 of an inch off, which means I'm slightly parallelogram. But I think I should be able to compensate that whenever I put the triangle up front. I just have to do careful math there. But other than that, I'm happy. So next, I'm just going to go ahead and tack these up off camera, and when we come back, I'll talk about how I'm going to be doing the full weld. Well, there you go. I have all my slates tacked up, all the corners are tacked up, all the corner braces are tacked up, so this thing is fully tacked in together, and it's fairly sturdy right now. So now we come to this idea of planned incompetence, because I know my welding skill levels. I'm halfway decent at welding flat joints, miters and stuff like that. I can do 90-degree joints, because in both of those, gravity is working with me. Welding up and down, I suck. I've practiced at it. I've done a lot of experiments, taken even some tips from people, starting at the bottom, working away. But I'm just not very good at that one. So I've got to plan for those kind of incompetencies. So right now, I'm going to weld everything that is flat or a 90 degrees and still flat on this face. And then we'll do a few tricks to compensate for those inadequacies I have. Flipping the trailer over was such a stupid, simple solution to me having to avoid welding upside down at all costs. It almost felt like cheating. And with this idea of planned incompetence and that I'm not very good at welding vertically, I want to kind of do the same thing. In order to accomplish that, I'm going to go ahead and install 2 of the 5 receiver hitches that I had planned for this project now. And I think you'll be able to figure out why. In order to get this special receiver hitch metal, which is fairly thick 2x2, I had to order a 20-foot section of it. But what that allowed me to do is cut it in 2 different parts. And on this part, it is now long enough that I have myself an axis. And what can you do with an axis? You can rotate around it, thus turning your vertical welds into horizontal welds. So now that the bed of the trailer is done, I'm going to move on to the tongue. Now, for most people building just a backyard utility trailer, this actually is a fairly simple task. You can buy these pre-made tongues, which are 50 degrees. That's really a smart idea because they're easily replaceable. You can just about get them anywhere. They're inexpensive and stuff like that. And with them, you basically just place them forward however far you want to get the 50 degrees down to where it connects on both sides. The key thing is you need to make sure you get it far enough forward that on your tow vehicle, you take the center of your tow vehicle, come out to both sides, and you want that distance right there to be at least this far forward. That way you can actually turn your vehicle and get the most turning radius without hitting your trailer with the back corner of whatever your tow vehicle is. Now I'm going to do something a little bit different, but it's not that unconventional. I'm going to use a receiver hitch for the vehicle's tongue, the trailer's tongue. In that receiver hitch bar that I'm using as the axis, I'm going to take a section of that and I'm just going to weld on the tongue section to it so that this will slide into the receiver hitch of the trailer. That way I can remove it, and it's somewhat of a basic security thing because a lot of people are going to be stealing a trailer. They just want to load it up on the ball in their truck. They don't want to have to fiddle around and make a lot of noise and that kind of stuff. It's not that complex thing to overcome. They just need to make their own, but not too many people have that set up. The other thing is I'm actually not done with the bed. I'm going to be putting a toolbox on front. And then I want the capacity to put my motorcycle right here, okay? So that, the motorcycle alone, you know, I'll probably be trading out of what I'm riding now because it's almost 600 pounds. But until that time, I like to be able to take it. That's going to add a lot of tongue weight. So if I can extend the tongue a little bit, it'll make a lot of difference as far as tracking. Also, that means that I'm carrying a lot of weight towards the front of my trailer instead of towards the middle. So that adjustability will enhance stability. But that also means that I can't use that 50 degrees because that would be putting my axis way outside the bed. So I'm going to be using angles probably similar more to boat trailers. It's fairly steep. But that angle doesn't really matter for me because I'm using that receiver hitch for the tongue. So from here, I just need to put my receiver hitch so far enough forward that that distance right there is more than half the width of my truck, my tow vehicle, so that when I'm making my turns, I'm not going to be banging into the trailer or the motorcycle. But in actuality, I'm probably going to make it quite a bit farther just to reduce that weight, as I talked before, because that's 600 pounds, very close to the trailer hitch. But once I figure that point, that will give me a nice angle. And I want to come back on those bars pretty close to where the axle is going to be, because the farther this distance is from this distance is, the more strength you're going to have, because that right there becomes a pivot point for the torque pulling on that side. So if you can get it longer, it'll be less torque on that one point. So all that's left to do is measure and do it. Now, as I said earlier, I'm not the greatest designer in the world. I can't just lay something out pencil paper or go into CAD or something like that to produce plans. Generally, what y'all saw on the whiteboard is as far as I go on most of my designs, even furniture and stuff like that. And this isn't a perfect example. You know, I knew that I was going to be coming in here. I knew that these was bigger than this piece right here, and I knew I would be fitting it. So basically what it came down to, as you saw in the montage, was I just position one piece up to another and draw lines of it. If I need to move it over, I go, well, I got to remove this part of the material. So right now I'm fitting it, and I could see that coming up to it, I need to remove, grind away that right there, and I need to flatten this bevel right there in order to get these together so I can weld it all up. It's a little bit of trial and error, but it's simple for me to do it this way. I don't feel, I'm not stressing as much. I know you can make two parts fit together if you just put them together and see what needs to be removed to make them go. So being incompetent at computer designing isn't that big a deal. At least for, you know, human scale stuff. Now, one other issue I ran into, just checking alignment of everything, I noticed that whenever I line up these two receiver hitches with the end post right there, it is about 1 inch too far to my left right now. But that wasn't the case when I lined it up before welding it. So I think my welding action, maybe I put too much heat on one side compared to the other and it moved the metal. But I can solve that with a little bit of brute force. I just need to move it about 1 inch this way. The next thing we need to install are those axle attachment hangers, and this is the most accurate we have to be. This is one of the few things that can really affect safety, because if you get the axle off a little bit, me dramatizing, well, it's still going to want to track straight, so it will dogleg to the side, and if you have wind blast on one side more than the other side, that could be the part that induces the trailer sway, which we do not want. So we really do need to get this axle just dead perfect in alignment. And what I mean by that is taking the center right there of where the trailer attaches to your vehicle, and the distance from that point to this side where the axle is and this side where the axle is has to be identical. That way it forms a triangle where both legs are exactly the same size. That way it would track exactly behind your vehicle, even if the geometry is a little bit off. That's also why I said earlier when I was welding up this frame that it was more important to get these two sides parallel than these two sides being somewhat of a polygram. So I ran into a problem. Unfortunately, I did not think that through before welding these beams on right here, because in order to go from the center of this point right there to wherever the axle needs to be over there, the string that, or the tape measure I would use would have to go over this. And because these aren't identical, you know, it might go over the bar a few inches one way or the other, which would dramatically affect the length of that string and where it would be located. So I can't do that anymore. To overcome that problem, I did this. I took a measurement from that center section, but instead of coming all the way back to where I want the axle to be, I came to a point about a foot behind the leg and came up with that distance right there. And basically it was a perfect 10 feet. I then did the same thing to this side and got a perfect 10 feet. The reason why I didn't go to those corners is this could have been that polygram. And I did recheck these distances and they are the same. So I know those are parallel. From there, I basically have that perfect triangle to that distance. So I can now just take a measurement point and come down to wherever I want my axle to be. Now there is a general rule of where you want to place your axle on your trailer, a utility trailer. And if all the weight you're going to have is on this trailer right here, you basically want to have what they call the 60-40 rule. So if that is directly in half, you come down so that 60% of the weight of the vehicle is going to be up behind, in front of the axle, and 40% behind. That will put a little bit of weight on the tongue and it will track stably. If you want to understand about that swaying action, things becoming unstable, just Google that on YouTube and it will show you all those reasons why. But if you remember, I'm building a teardrop. And a lot of times teardrops, they put the axle farther back because they will have a refrigerator, a AC unit, a big water tank, your water heater, all the weight's towards the back of the trailer. And the only thing that's up front is a bed. So it's carrying a lot of weight back there. So they will locate the axle farther back in order to achieve that 60-40 ratio. Me, on the other hand, I've got that tongue box, which I'm going to be carrying a lot of stuff in, and an occasional motorcycle. So I'm actually going to go for 50%, hoping that that will give me my 50% that distance-wise, understanding that even though I will still have that same weight in the back of other trailers, the weight I have up front will offset it. So in order to become balanced, I need to go a little bit forward. But that's just me. Most people, you're going to put the axle a little bit towards the rear, 60-40. Now, just to clarify, I have the most basic of suspensions you can get, and they call it dual eyelet because you have one eyelet on this side and one eyelet on that side that a bolt is going to go through. Now, those eyelets get attached to the trailer via these shackles. And a lot of y'all probably already know this, but I didn't. The shackles come in two different sizes. Basically, you have a wide one and a short one narrow one that are narrow enough to fit inside those. That is because, well, the front springs towards the truck, they're going to attach to these, and these are going to be welded straight to the frame, bolts going through the eyelets and this thing right here. But you can't bolt a spring to the trailer solidly on both ends. See, a spring has to kind of flex out. It stretches out as it gets compressed. So the back of it has to move. Hence, they give you these little things right here. And if you notice, the thin one plus these are the same width. So it's these two add up to the same width as the back ones. So basically, you'll put a bolt through these two, and then you'll bolt this to the spring so that now that the spring can move. But you have to do it in a certain way. Let's pretend this is the spring. This is right here. You can't have this little dog leg going forward because then the spring will actually bind up because it's being pressed down, but this has to go up in order to flex back. So you always have to have it kind of canted back from the spring so that it's always it works. It doesn't bind up as much. Now, that means that this cannot be, attaching these two cannot be the same exact distance as the two eyelets on that spring. To get the distance that you need to measure in between this center of this eyelet and the center of that eyelet, just contact the manufacturer. It's generally written down somewhere. They have specifics for each spring they sell. So from there, draw a line through the center of the eye hole, then go to where you want the trailer axle to be. Take the distance that the manufacturer told you to go between the two eyelets, and take half of that and go forward, half of that go backwards, and that way you know that the axle will end up exactly where you want it to be. Then it's just a matter of welding these on in the right spot. Now for a lot of people, this trailer is now ready to rock and roll. I mean, just drop it down on the springs, you know, put your lights and wires on it and go. But I took a day or two to do some things that are unique to my teardrop, so I'm just going to gloss over those. Things such as installing some safety chain hook anchors. I installed receiver hitches on both ends, and I did it on the very outside so that I could align them with the side right there. That way I knew they were perfectly parallel. This will allow me to do a lot of different things, including making little racks that will slide into there, because I always hate the racks that slide into a single receiver hitch because they constantly rattle around. I never feel they're stable. But I could also build a small bumper right on back in case I back into things quite a bit without damaging it. That could be removed and put on the ground so it won't hit your shins whenever you're cooking in the back of the teardrop. And because it is a teardrop, I installed stabilizer jacks on either side. Now those are up a little bit right now. They will come down so that the rollers that I installed on top of the receiver hitches, they will actually be the first things to hit the ground. That way, whenever I'm leaving something like a gas station or something like that, I'm not going to damage my trailer. Those will hit and roll. And in case I ever do want to put anything on that back in a little platform, I did go ahead and put 2 D-rings back here, and I'm going to be putting D-rings at various spots around my trailer. Then there was the infamous spare tire holder. Now, one trailer accessory I think a lot of y'all might be interested in how I'm doing is my spare tire holder. Now, I've been trying to think of ways to do this for a long time. I could put it on the side of the trailer. You see a lot of people do that one. I personally think it's kind of ugly there. And actually, there's other uses for the sides of my trailer that I can think of. Some people will use these U-bolts and put them up on the tongue, but I'm going to have so much weight up there already. I just didn't want to do that one. I really did want to keep not only the weight more towards the axles, but low. Keep the low center of gravity low. It'll handle better that way. I really did want an underbody mount. And as strange as it sounds, there are so few options for underbody mounts on trailers and RVs. I even investigated, this was a total waste of my money, one of these winch things that winches it up and stuff like that. $50 I'm never getting back because I passed a 60-day mark. I eventually came up with the idea that I was just going to get a plate, move it across, and put 2 bolts through it that I could put through the lug nuts of the tire and just kind of bolt it on that way. You would not believe how hard it is to get a 1/2 inch 20 thread count, which is standard for all axle bolts and stuff like that, that even I got on my trailers, so it would work with lug nuts, so I wouldn't damage the wheel as I bolted up there. I needed that angle right there on the lug nut. I went everywhere for it. Finally, I went to this podunk little trailer place that sold trailers and talked to them, and he took me in back. He wanted to show me one of those side-mounted things that he said, well, if you're welding it, just cut it in half and put it up there. And it was almost $60. And then over on the corner, I saw this. An entire, I don't know what it's called, hub, axle, whatever. This goes on the spindle. You put the bearings here. Y'all saw me do that the other day. You know how much this is? $20. You know what I'm going to do? I'm just going to take this. I'm going to weld it to that. And now I have a place to put my spare tire underneath the trailer. This little block right here will just get it up enough so that my tire will not be touching anything other than this, so it will last longer. So that's what I'm going to do now. Well, this to this, this to that. Now I have my spare tire hanger for $20 and a piece of scrap that I had from the trailer build earlier. So the last thing I need to do before I flip it over and put the suspension on is put a cross beam right here across the tongue. Why? Well, all the pictures I see of people that have this design have that cross beam there. I have no clue what function it serves, but they do it, so I'm going to do it. And what that's going to involve is cutting it to length and then using my highly skilled methods for laying out the stuff I need to cut out so they fit together, and then welding it on. And since the triangle was already there, and a while back I picked up some steel from a sign making place, one of their offcuts, I just plasmed out the triangle and welded it on, so now I have some place to secure stuff. Also, last night I recognized that at the end of the bed, there's no support for plywood, so it would be kind of floppy. So I'm going to cut a few pieces of angle iron just so plywood will rest on it for the foundation of my teardrop. Next, I want to make the frame for the toolbox, but there's really no need to film and discuss that with y'all. It's the same exact thing I did for making the bed. It's cutting the length, mitering the corners, and welding it up. So when we come back, how about we go ahead and get that suspension on? Now, if all possible, I'm going to try to get this mounted while it's still on the rotisserie, just because A, it'll make it easier getting it off the rotisserie, and B, welding up the braces and stuff for the fenders and stuff, I think will be easier on my back. It is a little higher. Man, this is gonna really suck if after all this I did the measurements wrong. Anyways, first thing I'm doing is putting those little arms on these hangers. Weird, the end of the bolt right there has some threads on it, so it won't all go. I guess it's going to compress as I put pressure on. Okay, yeah, that threading on that will feed into this, and it kind of locks it all together. So be sure you keep that in the right spot for whatever you want to do. And here's something else I just figured out because I tried to put it on the wrong way. Notice that they've punched it in 3 different spots on this side, and if you look at it, it destroyed the threads. So if you put the bolt in coming in this way, well, basically it'll thread through, and then as it goes down deeper, it destroys itself as it works its way out. That way, this won't work. This won't unbolt itself as it's vibrating going down the road, because it's basically destroyed the exit. It's a pretty simple solution. Well, shit. So this ought to be for a good laugh. I've got the backs bolted lightly, but they're secure, so I just need to get this spring up here. So what I'm thinking is using this strap as a winch and winching up the center of the axle, and now make those come up. What do you think? Crash and burn? Let's find out. Dad's saying no.
Why don't you just use this winch you got tied to the trestle, hook this and just lower it down real slow? Wouldn't that work just as well?
Okay, you're making me look stupid.
Well, that's not hard to do.
Yeah, well, you watch the back sawhorse, make sure it doesn't start to tilt. Winch is armed.
Winch is armed.
Going down. Apollo has landed. Okay, we got 1 more inch to go, so Dad's idea is to use a woodworking clamp as a jack to just get it up that 1 inch. And this seems to be working. Fourth time's the charm. Okay, people, we will be editing out how we got that last bolt in for those of y'all with delicate ears. So tomorrow, we will start working on the bracing for the fender and anything else we need up here. But at this height, at least I'm not bending over all day doing that kind of stuff. Now this top section where I'm putting my toolbox, it is right under 24 inches, and so is this bottom section right here, which will eventually be the bike rack. Now this 4x8 sheet, it ran me about 125 bucks, so I don't want to waste any of it. So I can actually rip this right down the center and save the second half for another project later on down the road. Since this is so big, I'm gonna go ahead and do this now just to get it out of the way and get the fenders right after that. So last night I finished tacking on the expanded metal, and then I trimmed it out with some angle iron just so I wouldn't be catching stuff coming up on the side. And I'm actually going to do the same kind of concept on the pieces that I'm going to have holding up the fenders. Let me explain. The fenders as they come really don't have any installation setup or something like that. Basically you just screw this to the side of the trailer and these just hang out in the wind, which is why they get damaged so much. So I actually want to support it along the side, which, you know, a simple tack weld will be just fine. But the fact that it's curved means that, you know, if you put something square to it, you're going to have that gap that's going to catch water and everything, which would just lead to rust and stuff. So my idea is I'm going to build a small platform on either side. It's not going to come out to the edge of the wheel, but it'll give me a place to put like water cans and stuff like that. I'm going to use that as the attachment point right here by simply using the angle iron to hold down some of that expanded metal to make the platform. But then I can weld on a second piece of angle iron on the side. And that will give me one contact point instead of two that can attach right there, and it won't accumulate water. With all those small parts cut, I finally get to use this giant metal workbench I built out of the junkyard scrap in the way it was intended. Me comfortably sitting down to weld together little sub-assemblies I can put elsewhere. So I finished all my sub-assemblies. This is the one that's going by the door, so it's kind of short because I need to have a step forward. And I went ahead and put solid metal on it instead of that expanded metal for the simple reason I have a feeling I'm going to be using this as a place to kind of rub off my boots, and dirt would accumulate in that expanded metal. This stuff I could either hose it off or just wipe it down. It'll be easier to keep clean. Now I have a problem in that I wanted to mount it so this was flush with the underside of the chassis. That way it'll be level with the frame. And I can do that when I don't have anything there. I just put a clamp right here and I can kind of rest it right on top. My problem is I got a lot of spots where I'm right here. So what I'm going to do is just rest one side on the clamp and kind of eyeball it and just tack it on like that. And that'll be professional enough for what I want to do. Also, you'll notice I've got crosshairs right here because that's actually where I want this end angle iron to be. to weld or tack to the wheel arches. And I've got it a tad bit, you know, we're talking maybe an eighth too close to the ideal situation, with the idea of planned incompetence. If I screw something up, I can always grind this down a little bit fairly easily to get it to the exact spot where I want my fender to be. So let's go ahead and get these attached and we're almost done. And there we go. The trailer is on the ground and ready to roll away. All that's left to do is paint it and do the wiring. Now, I did say that for me, this is a teardrop foundation. So I am going to have a video on wiring up a teardrop trailer, which is going to include not only the wiring of the trailer, but the cabin and the RV part and stuff like that. So I'm just putting all electrical in one video, plumbing in another video, framing, that kind of stuff. So please, like, favorite, subscribe, come back for more if you're interested in that kind of stuff and to see where this thing goes in the future. And for those of y'all that were wondering about my welding ability, because I was, well, this entire video, y'all have watched it sit, the entire weight of this trailer be rotated around, banged around, that kind of stuff, on one 4-inch weld down there, or I guess two on either side of that receiver hitch back there. All the weight of this entire thing has been held right there, no problems whatsoever. So I think in conglomeration with all the welds together, I'll be okay, especially for a 2,000 pound or less RV. Well, I hope you enjoyed this little adventure. I can't say you could pick up any tips or tricks from me because I'm a beginner at this, but it's fun while we went along. Y'all be safe, have fun, and remember, it's always worth the effort to learn, create stuff, and share with others. Be safe, have fun.